you just finally get to meet me. All right, any other questions? Let's talk about inheritance. Okay, so we're going to learn inheritance through example. I'm going to build some functionality of a game. Just disclosure, we're not actually going to build this game as fun as that would be. Lectures are just stuffed as it is. We can't go through the whole game. Maybe someday I'll build the whole thing and then just release it, put it in the examples repo for anyone who's interested. But we won't build the full game, so don't get your hopes too high up. But we will build some functionality. And what we want is a game that's going to have 2 items, health potions and weapons. Health potions can increase a player's health, can restore their health, and weapons that can increase a player's damage output. So pretty simple game. Today we're not even going to see the player class. On Wednesday we will. But let's see our game with weapon and health potion and build the functionality for these 2, or at least simulated functionality. Enough to motivate inheritance. So here's the health potion class. Not too much going on here. I hope this is relatively calm material right here. Health potion, 3 instance variables. Increase is the amount of health that's going to be restored when the health potion is used. X location and Y location, I'm thinking of a 2D top-down perspective game where every object has a location in this XY plane. So we have 3 instance variables for those values, a constructor that lets you initialize those 3 values. So we're saying none of these values are going to be the same for all health potions. Every health potion can start in a different location and have different values for how much health it's going to restore. And then a use method that is just simulated for now. We don't have a player class yet. Is going to print to the screen how many health points were healed. So just simulating it for now. But we know how to do all that. We could have used this example 2 weeks ago, and you would have understood everything that's going on right here. This is just a class. It's got a constructor. Constructor takes parameters. We have instance variables. This is all old hat to us. We've seen it before. So what are we learning today? Inheritance. Yay. So this is inheritance. Let's refactor the code. This code does the same thing as the code on the previous slide, but we're setting it up in a very different way. So now instead of just the health potion class that has all of that functionality, we're creating a second class, game item, and inheriting game item in health potion. So health potion is going to extend game item, which means it gets all of the state and behavior from the game item class. So let's take a look at this one. First, we created a second class. This will go in a separate file. We'll have gameitem.java, create this class in a separate file, and give it everything that a game item should have. So what we're eventually setting up here is a game item class that's going to store all of the state and behavior of a game item that every single item type in our game should have. Right now it's just health potion, but we're going to bring in weapon as well. And anything that's common between those 2 classes, we're going to put in the game item class and say every game item should have location in our case. Every game item needs a location in this XY grid, in this game world. So we're going to put that in the game item class. And then in health potion, all the code in the health potion class is only concerned about health potion specific stuff. That's our ultimate goal. So let's see how we accomplish that. We extend game item. Extends game item. This is where inheritance comes into play. This is saying health potion inherits from game item. We use the keyword extends to say that. So we'll often just say health potion extends game item. This is going to take all of the state and behavior in game item and stuff it in the health potion class. State, just a reminder, when I say state, I mean all the instance variables. When I say behavior, I mean all of the methods. So health potion gets all of the instance variables and methods from the game item class as if all of this code were in this class. With a little bit of difference, the constructor we're going to talk about behaves a little bit differently, but it's effectively like all of that code is in the health potion class when it inherits all of that state and behavior. There are nuanced differences. We ain't going to worry about that quite yet. But the constructor is the big, non-so-nuanced difference. So the state, we inherit all the state from game item. That's all the instance variables. So when we create a health potion object, that object, of course, will have an instance variable named increase, but it will also inherit these two instance variables, x location and y location, from the game item class. So a health potion object is going to have three instance variables, the two inherited variables and the one health potion specific variable. So we gain two instance variables through inheritance without having to have those instance variables in this class. And we also inherit all of the behavior, so all of the methods. Right now it's just one constructor. We'll expand this as we go throughout the day and then throughout the week even. Right now it's just the constructor, which we handle a little bit differently. So constructors with inheritance, if and when there are more methods here, it's just like those methods were cut and paste in this class. But the constructor, let's talk about constructors for a bit. And this is going to be probably the biggest topic that I talk about with inheritance is these dang constructors. They're trippy, they're a little confusing. We're going to talk about it. First vocab, and then constructors. When we have this set up, you're going to hear me use these terms, so let's get used to them right now. We're going to say the game item class is the superclass of health potion, or game item is the parent class of health potion, or the other way around, health potion is a subclass of game item, or health potion is a child class of game item. For whatever reason, I don't know what's going on in my brain, but I tend to mix these. I'll use superclass and child class as my terms, my vocab terms when I'm talking about inheritance. So if I say child class and superclass, those are the ones I stick to. Sometimes I'll say subclass and parent, but I don't know, superclass and child class are the ones that stuck with me. But if anyone, me or anyone else says superclass or parent class, those can be used interchangeably. And subclass and child class, those can be used interchangeably. So just like way too many things, we have multiple words for the same thing. I wish it weren't the case, but I wish I didn't even have the option to mix these in my brain. But we got multiple terms for the same thing, so we just got to learn multiple terms. It's what it is. Drives me nuts, but just there's nothing I can do about it. Yeah.
So by using extenders like game item and health class, does a fusion and then the stuff from class health potion is out of that independent of game item?
No, almost. So it's not quite a fusion because game item doesn't change at all. Game item, in fact, doesn't even know that this is happening. Game item just happily exists on its own without knowing about a health potion at all. But health potion gets the fusion of these two classes. So health potion gets all of the state and behavior from both classes. So it's a one-way inheritance.
Wait, then why is health potion called the child and game item called super?
For our so super is important. That's actually gonna come up in our code even. Super is important. The subclass, child class terminology, that's just for us humans to talk about it. But the game item doesn't know that it has any child classes. Yeah. No. Of the constructors?
Oh, yeah.
Right. No. And they're not on screen either. I have an extra param here. Oh, no, not to that either. Say we don't want to take these parameters here, and we want our health potions to, by default, start at 0, 0. I would say super 0, 0. And then just take increase as a health potion constructor param. That'd be perfectly legal. But when I call, actually, let me get it on slide. When I call the superclass constructor, I do have to provide the arguments matching the parameters. That's the only criteria. But this is just like any other method call. So however I get those arguments is up to me. Right here, I'm choosing to take them in the constructor and then just forward the values to the next call. But I don't have to do that. I can do whatever I want. And so can you. When you're coding, you can do whatever you want in this case. As long as you make that superclass constructor call. which is the first time I'm going to say it, not the last. I'll probably say this at least 20 times this week, and then everybody's going to know it, and nobody's going to make this mistake on the memory diagrams. The superclass constructor must always be called when you call a child class constructor. So when the health potion constructor is called, the superclass constructor must be called. Every single time, 100% of the time, no exceptions. It is called every time. Here, we're calling it using the super keyword, and then using super kind of in place of the class name, the superclass name, and calling it just like we do another constructor where it's the class name and then parentheses and calling the constructor. So this is a super constructor call or a superclass constructor call that's going to call this class in it, this constructor, and it has to always be called. Yeah.
We're not accessing xlog and malloc. If you want to do that, we'll do this super not xlog.
Yes, but it wouldn't work in this example.
Like if you want to access, because we just said it, where is it going?
With the code we have on screen, nowhere. Like this code is useless right now because we have private instance variables and no getters, no methods that do anything with them. So those values are just locked up there. So we'd have to add some public methods to be able to work with them. So you would normally, if I wanted to, this is getting a little ahead of things, but I'm fine with that. If I wanted to access, I don't have anything that can be accessed here, dang it. But if I had a public method here and I want to call it from my health potion class, I can use the same keyword and use super dot and then the method name to access it. I can't access my variables because they're private. Private does mean private. That's a very powerful keyword. It means these variables can only be accessed from within the class, from within the braces of the class. That does even exclude child classes. Child classes can't access private variables, even though the health potion class, like those variables are part of its objects. That class still can't access those instance variables. To get around that, if we wanted to get around that, we would use the keyword protected, but I don't plan on talking about that in this course at all, actually. I think maybe I should just add it, but I don't know. There's a lot in 116 already. I thought I saw another question. Is there still? Or was it in chat? If you don't have a constructor from the parent class, does super create a basic constructor for you? Yes. Yes. Throughout the week, we're going to see, there's a few different ways I can interpret that question without too careful of a reading. And we will talk about all of them throughout the week. So one of them is on the next slide. I say the superclass constructor always is called. But if you've done inheritance in Java before, you might have done something like this, where I don't call it. That's why I'm very careful with my wording. It is always called, even if you don't explicitly call it. So I have this code here. I'm not calling the super constructor, but if the superclass constructor doesn't take any parameters, then the superclass call in your code is optional. I could write super open paren, close paren, semicolon, and it'll have the same exact effect as the way the code is written. If the superclass constructor takes no parameters, Java's smart enough to know, well, Java itself has 0 IQ, but the Java devs are smart enough to know that you have to call that superclass constructor. And if that superclass constructor doesn't take any parameters, there's no choices for you to make. Like, it's just it has to be called, whether you call it explicitly or not. Java's just going to do the thing that has to happen. So always has to be called, but sometimes Java's just going to call it for you if it takes no parameters. So I can explicitly put my call here or leave it out. That constructor is still being called. Superclass constructor is always called. The other part of that question, just to answer it now, is if I delete this and I don't have a constructor in game item, there still is a constructor. It's the default constructor. I mentioned it briefly earlier in the semester. It gets the default constructor, which is a constructor that takes no parameters and has no body. It's just this, but open brace, close brace without any code. And if I don't put a explicit call here, I have a lot of implicit code that's happening. I have an implicit call to the superconstructor that takes no parameters that isn't explicit. I just got the default constructor by default, and all of that stuff still happens even though none of it's explicit in my code. The superclass constructor is always called, though. The longer we go, the more I feel my brain's melted. That's why a lot of those auxiliary topics I try to trim up a little bit, because 116 is a lot. Like, we just learned what classes and objects were 2 weeks ago, and now you already know linked lists, and we're jumping onto inheritance. That's kind of crazy. It's fast. So do you have to write super as well as X location and Y location are the parameters of the health potion part, or is that still mandatory? Let me get back to this code and why. Why would we ever do this? Is the question I want to ask. So since my constructor takes parameters, I have to explicitly call it, and I don't need these parameters like we said before. If I want to pick different values for these, I can put 0, 0, or 10, negative 50. I can just put values, like literal double values here, instead of taking them as parameters here. But I'm doing this so when I create a health potion, I can still provide the initial location of this health potion and forward those values to the superclass constructor to get that location. I think that's what was being asked here. Yes, you can. Can I create a child class of the health potion class? Yes. I want to talk about that. I'll revisit that in a second here because the example makes more sense with the weapon class. But yes, the short answer is yes. My question to you is, why would we ever do this? This looks dumb. Like, why would we do this? We had the health potion class with the 3 instance variables and without the superclass constructor call, and it was less complex than what we have on screen, and we didn't have to know what inheritance was. We never had to learn inheritance to do that. So why would we even do this? We added complexity. We added another thing we have to learn to get what? Nothing. The same functionality. It's dumb. So let's talk about why. The why starts to be more important when we have multiple classes both extending the same class. This is where we get some power out of inheritance. The true power, to be honest, I think the true power is when we get polymorphism. We need inheritance to do polymorphism. That's not for like 4 weeks. Inheritance alone, we still do get quite a bit of power, though. So let's talk about what we get. If we have weapon and health potion both extending game item, the game item functionality, the state and behavior, we only have to write one time. We write it once, and then that code shows up in both of these classes. Not the code itself, but that state and behavior exists in both classes. Now, every game item, we want to have this location functionality, so we put it in the game item class, and now weapons and health potions have that location functionality. Getting back to this question, can we have another class extend these classes? Yes. So weapon is very vague. That's why I like this as the example for this. Weapon is very vague. What's a weapon? Realistically, we would have weapon types that are going to extend this. I would have a class, let's say nunchucks, that extends weapon. I don't know why that came to mind, but nunchucks extends weapon, and weapon extends game item. So we can have different types of weapons extending the weapon class. And weapon is just defining, okay, if you're a weapon, you're going to have some amount of damage that you deal, and then each specific weapon might have more specific functionality. Maybe I have a grenade weapon, and I want to implement splash damage when there's an explosion and a timer. I would put that functionality in grenade, but then the damage itself can still just be in the weapon class. And then location stuff is going in the game item class. When I create a new class, what I want is to only think about the functionality of that class. Weapon is only talking about damage. Aside from forwarding X location, Y location to the superclass, it just has stuff about damage. Health potion only has stuff about healing. That's what I want. Now when I create that third item, because pretty boring game so far, health potions and weapon, generic weapon, it's not any type of weapon, pretty boring game. I create that third game item, I extend game item, and then just think about what that third item should do. I want to add vehicles to my game. extend game item as location, and then I start working from there. And when it's just the constructor and 2 instance variables, still, I can just cut and paste, right? But when we start adding more functionality, I want these things to move. Like so far, nothing could even move. It was private instance variables and no methods to modify them. So whatever you gave the constructor, that's where that object is forever. That's kind of boring. So let's add a move method. Instead of writing it, what we would do before this, we would write it in the weapon class, right? We write our move method. It looks great. We love it. Copy, paste, and get it into the health potion class. Which, it's not the worst thing. But what we'll do here is write that one time and now have it extended in both. So this method effectively exists in both classes, but we only write it one time. Where this really comes in handy above cut and paste is an easy way to write bugs when you update the code. So copy and pasting when you first write it, it's not that bad. But when you update the code, I want to change the move method to have a third dimension. I want to add a z dimension to this and let my objects have some height. And then I want to add some physics to my objects, add another method where I can give my objects velocity. And when I throw them, they're going to have a nice parabolic curve because gravity will be applied on each frame. And I have really nice movement mechanics to my game objects, to my game items. And then maybe I want to add colliders and everything. I want to write all that functionality in game item. Honestly, I'd write it in a separate class for my physics engine. But I would write it in my game item class in this example, get all that code, might be hundreds of lines of code to get all that functionality. I'll write it here, and then every class that extends game item just has that code. And if I'm writing that much code and I'm cut and pasting, finding out I have a bug where objects can clip through the floor, I fix that bug. Now I got to go through each of my classes, copy the fix, paste it. It gets tedious. It gets exhausting. And your classes get really cluttered. If I put it all in game item, I write the code once, I test it once, I debug it once, and maybe there are later bugs down the road. I update it. When I want to update it, I just update it once and go through the process again. And then all of my classes that extend game item get all of that functionality. I only write the code one time. That's what we want. Whenever we have duplicate code that we're cut and pasting, it's usually an indicator that we can do things better. And okay, with 2 game items, you might argue against me with a lot of that stuff. There's a lot of overhead to learning inheritance and understanding all its nuances. But what happens when we have hundreds of game items? You release your game, you add a few more, and your users are like, man, I'd really like to fire a bow and arrow in this game. And I want the arrow to follow a nice, I can aim any way I want and have all the physics apply and all that stuff with colliders. Public class bow and arrow extends game item. Public class arrow, you probably want arrow objects too, extends game item. It gets all of the location, physics, colliders, gets all of that functionality, and then you just implement what's specific to bow and arrows. Use a bow and arrow is going to create an arrow object with certain velocity and a direction, depending on which way the player is facing. Then arrow is going to get that velocity. And then game object, or the game item class, takes over from there. That arrow follows that physics. That's what we want. We want it easy to expand our games. This course is all about what happens when our programs get big. We have hundreds of game item types. We want it to be easy to add that next one. We want it to be really easy. To add a new item like this, where all the complex stuff is in game item, weapon and health potion, even with all of that physics and collisions and everything, these 2 classes should still be this complex. Pretty simple, which is pretty simple. Less than 10 lines here. That's what we get from inheritance. Yep.
Okay, what happens if you did something like extend inception? Like you have weapon extends game time, and then you have increase person extends weapon. What would happen there?
It would just work. I don't. So if you extend weapon, that class gets all the state and behavior of weapon, which already has all the state and behavior of game item. So you get all of the state and behavior of both classes. And and that goes like all the, you can have very long, we call them inheritance chains or inheritance trees even, because they can branch, and they can go down as far as you want them to. I might want weapon, I want sword that extends weapon, and I want different types of swords, all extending sword. I can keep going down. And each one that goes down gets all of the state and behavior of everything that came before it. Yep. No, can't do it. So that's like the one thing you can't do. So I'm always ready for this question. It comes up every lecture. So sorry about my reaction like that. But this that's one thing that you can't do with inheritance. Extends game item and something else. Can't do it. But we can kind of do the same thing where when we do have sword extends weapon, extends game item. Sword does extend weapon and game item, but indirectly. You can only directly extend one single class. There are things, we won't talk about them until Polymorphism Week, but there's things called interfaces, and you can implement multiple interfaces. So weapon extends game item, that's its one extension that it gets, and then implements multiple interfaces. Interfaces are kind of like classes that don't have any functionality. They have only what's called abstract methods. And then we can get multiple inheritance, but not with classes. So that's my hopefully I got that pretty succinct. That's my abbreviated answer to that question. Yeah. Mm-hmm. Yeah, that was my answer over here too. Like if we have sword extends weapon and weapon extends game item, sword will get all the state and behavior from both classes. And what we're going to see by the end of this lecture, game item actually does extend something. It extends the object class. So we actually, even on screen right now, we have that inheritance chain. Weapon extends game item, and game item extends object. So weapon, by transitivity, does extend object. It does extend two classes, but it has to be transitive like that. I can't say weapon extends game item and object. Okay, any other questions? Bless you. This is inheritance. We got a whole week about it, but that's the crux of it. Yep. You guys speak up a little. Mm-hmm. Yeah, so if I have an object of type weapon, I can call the move method. Yeah.
You said something about game item being a child of an object. Can you explain?
So the other way around, like weapon is the child class of the game item class. Health potion is a child class of the game item class. It's
then you said something about game item being extended from another object that we haven't, like, that isn't on this slide.
yes. I like at the end of lecture, I have a few slides about that. But there's a class that if you don't explicitly extend anything, you extend the object class. The abbreviated version of it is that's where we get toString and equals. It's from that object class. Yeah.
So, within your subclass, you have an instance variable that's the same name as your parent. Like, does this operator return the subclass's instance variable or the parent variable?
So the short answer is it's complicated. It depends on oh man, I got to remember my rules of this. So the shorter answer is don't do that. Change the names and use different names. Things start behaving really weird. You should get the instance variable of the class that you're working in. So like weapon, if if weapon had an X location instance variable, and I say this dot X location, I should get the one from the weapon class. But the weapon object does have two instance variables with the same name, and it depends where we are in the code for which one we're going to get. So inside the weapon class, we should get the one that's defined in the weapon class. But if we're in the game item class, we'll get the one in the game item class. So in game item, we might call move and expect our X location and Y location to change. And then in weapon, we do this dot X location, and it didn't change because it's two different variables with the same name in the same object. Things get really wonky, and we just don't do it. Unless you really understand the rules. And I went over them with Paul, the professor I co-teach with in the spring semesters, in the big, because it's a bigger class in 116 in the spring. We went through all the rules. We went through debuggers and saw all the behavior that happened. We looked at each other and said, there's no effing way we're doing this in class. It's just so complicated. All the rules are just all over the place. And in my personal coding, I don't want to remember those, so I just name them different things if I ever do that. Yeah.
So like the special methods?
Actually, I do think he had his hand up first. What's up? Not quite. So you can, like in Health Potion, super.x location, and then access the superclass constructors. In this example, we can't because they're private. Private means private. You can only access them from the game item class. Since these are not the game item class, even though they have copies of those instance variables, still can't access them because they're private. But in general, if they were public or protected, or default even, then we would be able to do that, yes. Would the sword constructor have super X location, Y location? If I had sword extends weapon in the sword constructor, I would have to say super X location, Y location, and I'd have to give it a damage. I'd have to call all three, give all three parameters. All right. Oh, yeah.
So like if we have the other methods like toString and all those, they are inherited as well, right?
Mm-hmm.
So let's say I don't define it for one of the child classes, what happens then?
It depends what the superclass has. Like for a toString, like if the superclass has a toString, you would inherit the overriding toString. All right, and we'll talk about overrides on Wednesday. That's a Wednesday topic. We'll talk about it in more depth. I'm always happy to get ahead, but I got to avoid falling behind right now. So let's get to the memory diagram. And there are two like brand new things for this memory diagram. I'm going to say a whole bunch of more times. I'm going to try to meet my quota of saying the superclass constructor is called when the child class constructor is called. So that's the first thing we're going to watch for. And the next thing is when a method is called, which method is called? This is pretty straightforward in this example, but I'm going to use this to explain why this is the case. It's simple in this example because we're going to call use, and we look at all our code. We only see one use method, so we know by deduction that's going to be called. And when we call move, there's only one move method in all the code, so we know this one's going to be called. That won't be the case on Wednesday. We'll see a more complex example where we actually have to understand the rules. So this is a warm-up to see what those rules are, what method gets called. So first constructor starts off normal as usual. We see new weapon. We're going to create a weapon object on the heap. We give it a random reference number. The constructor goes on the stack. This is a reference to the object being created. All the arguments go into the parameters in the stack frame. Everything usual so far. The next step, we're already deviating from what we normally know. Our instance variables are not just the instance variables from that class itself, but all of the inherited instance variables as well. We inherit all the state and behavior from game item, the state being X location and Y location instance variables. So we get these two instance variables in the weapon class and the damage variable in the weapon class. So we already got a little bit different, but the next thing, the superclass constructor call. The superclass constructor is always called when you create an object that inherits from another object. It's always called, and we're not going to forget those superclass constructors in our memory diagrams. It is a method call. It creates another stack frame. We create a stack frame for the game item constructor. It takes X location, Y location. We get X location, Y location from here. And this, I always say it's a reference to the object being created. It's still a reference to the object being created, and then there's only one object being created. We have two constructor calls, but only one object being created. So this is a reference to that same object that the child class constructor had as it's the object to the single object that's being created through two constructor stack frames. A shorthand for this is if you see the keyword new, you're creating a new object on the heap. If you don't see the keyword new, you're not creating a new object on the heap. So we're calling a constructor here, but we're not using the keyword new. We're not saying new super, we're just saying super. So that's kind of your mental note to help yourself remember. Calling another constructor, but not creating a new object, and the superclass constructor gets the same reference, that's one object being created. Don't forget your superclass constructor calls on your memory diagrams. That's an easy fail on inheritance. These really are the two things, the superclass constructor and which method gets called, the next thing we'll talk about. Those are like the two things I need to test you on in the inheritance memory diagrams. Missing either one of those is, you got to do the retake at that point. So don't forget your superclass constructor call. Nobody's going to forget because I'm going to say it 1,000 times, or at least 20, realistically 20 throughout the week. Yeah.
So if you want to call new super within the weapons class, do you just create a new weapons topic?
I don't know if you can actually do that. When I said it, I was thinking I've never tried that. I don't know. I would think no, but I've never tried it.
So new super is not like that.
Yeah, don't ever do new super. I've never done that in my life. I don't know why I said it like that. But you don't see new, so you're not creating a new object. I've never seen new super. I don't know if it's a thing or not. Then we execute the code in the constructor. As usual, this is the reference OX350, so this dot X location, this dot Y location, setting those instance variables to the object that's being created. That constructor call returns, and then this dot damage, set that equal to damage from the stack frame, and that constructor call returns. Then we return a reference to the object that was created, and don't forget your superclass constructor calls. They are always, 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 always called. Even if we don't have this explicit super, and there's a constructor that takes no parameters in the superclass, it's still called. It will be called. And notice, not what the slide says right now, but notice that in the game item constructor, this was actually a reference to an object of type weapon while we were executing the game item constructor. So as we get into inheritance, and especially polymorphism, we're going to have this blurring of the lines of strong typing, where we're going to have references to objects of different types that we might not necessarily be expecting in certain method calls. So in the game item constructor, this is a reference to something that's not of type game item. It's of type weapon in this example. So we'll see even more examples of that, which brings up the questions. The big question is, which methods are going to be called if I'm kind of blurring the lines of typing? Weapon.use, we call the use method from this object. This is going to be OX350. But how do we find the method that's going to be called? And I've been warming you up to this ever since we started talking about classes. We look at the type of the object, go to the class of that type, and look for the method. So we find a use method in the weapon class. That one's called. Easy enough. That's what we've done with regular classes. But what happens when we call the move method? We're going to call move, weapon.move. We look in the weapon class, and we don't find a method named move that takes two doubles. We don't find one. So when we don't find a method in the class, we move on to its superclass. We go into the game item class, and that's where we do find a move method that takes two doubles, and that's the one that's going to be called. So we move down our progression down to the superclass, and if we didn't find it in game item, we're going to move up to game item superclass and just keep moving up until we either find it or don't find it. If we don't find it, the program wouldn't have compiled. If we do find it, that's the method we call. So we call this move method. This method has side effects. It changes some instance variables on the heap. And then the program ends. I do want to get to the object, though. So if you don't explicitly extend anything, you implicitly extend object. These are the same classes with the same exact functionality.